There are three main things to measure when you're looking at waves: wave speed, frequency, and wavelength. Now, these are all connected through the equation wave speed equals frequency times wavelength. Now, wave speed is simply the speed at which a wave travels through a substance or medium. Frequency is simply how many times a wave passes a point per second. And wavelength is simply the distance between two identical points on neighbouring waves. Now, we measure wave speed in metres per second. We measure wavelength in metres. And we measure frequency in hertz. And hertz simply means per second. Now, it's quite difficult to measure waves in solids because you can't really see them and they're generally travelling. But one way we can measure them is to set up something called a standing wave. Now, a standing wave is simply a wave that is still. And we can set one up quite easily using this equipment. So I've got here a string. And the string is what the wave will travel through and what will be set up on. I'm going to give it a frequency by attaching it to a vibration generator, which is then attached to a signal generator. Now, the signal generator generates a frequency, such as 10, 20, 30 hertz. That's attached to the vibration generator, which vibrates at the same frequency. For example, if it vibrates at 30 hertz, the generator is vibrating 30 times a second. The string is also attached at the other end to a weight attached to a pulley. Now, this provides the tension for the string and allows it to vibrate. Finally, I have here a wooden bridge, and that wooden bridge is the point at which the wave will stop. After that, the vibrations are generally not going to bother the string. Now, I've set this wave up so that it is 1 metre in length. There is 1 metre between the generator and the bridge. I'm going to try and make a wave on this by turning on the signal generator. Now, you can see that the string is vibrating, but there's not a particularly clear pattern. To get one of those, I need to try and turn up the generator. Now, you can see that the wave pattern is becoming slightly clearer. And there we go. We've set up what we call a standing wave. It's not travelling anywhere, it's staying where it is. Now, this standing wave has a wavelength of 1 metre. If we have a look, the wave starts here, it goes this way and ends there. Now, it's really important to note that this is not the wavelength. Many people think it is. This is half a wavelength, so be careful with that. We also know the frequency of the wave because we just need to read it off here, and I can see that the frequency is 40.5 hertz. If I now wanted to calculate the wave speed, all I would need to do is put these two numbers into the equation. Wave speed equals frequency times wavelength, or 40.5 times 1. So this has a wave speed of 40.5 metres per second. Now, I can change the wavelength and see what that causes the frequency and the wave speed to do. And that's quite easy. All I need to do is move the bridge along. I'm going to move the bridge now to 90 centimetres or 0.9 metres. Now, the wave's gone a little bit less precise, so I'm going to increase the frequency again until I get a better version. And that appears to be happening there. If I go much further, we can see that it starts to destabilise. There we go. So now my wavelength is 0.9 metres, and my frequency is 45.3 hertz. Once again, I can multiply these two numbers together to get the wave speed. I can do this once more. I've moved the bridge so that the wave is now 80 centimetres long, or 0.8 metres. Once again, I increase the frequency. Now you can see the effects are getting much smaller as we decrease the wavelength. I think that's it there. So now we have a wavelength of 0.8 metres and a frequency of 51.8 hertz. And once again, multiplying those two numbers together will give me the wave speed. Now you could carry on this experiment. There's also many other factors that you could vary and see how it affects the wavelength, the frequency, and the speed. You could change the string, so you could have different masses or thicknesses of string. You could change the tension on the end of the wire or the string by adding masses onto the pulley and see what effects they cause. Now, measuring waves is difficult in a solid, and and it's hard to get precise measurements, but this is one solution and one method of doing this.